Hello, everyone. I wanted to make a couple of videos for you to help with Module 10. We had to just do one example of a couple of things, and so I wanted you to have more options to help. So with this one, we're going to work on our half angle identities. So here we have our half angle identities. These will be given to you on the exam. You don't need to memorize these, but you do need to know how to use these. And I had a couple questions after class, so I do want to clarify that in these identities, this entire fraction is underneath the radical in all of these. So in the top one, that 2 is also in the radical. In the cosine of x over 2, this 2 is under the radical. And in the tangent of x over 2, both the numerator and denominator are inside of that square root. So I want to clarify that whole fraction is underneath those radicals. That's going to change kind of what you have. So make sure you get that whole fraction underneath the radical. And then the other thing is, again, these all have pluses and minuses in them. You have to choose whether it's positive or negative, depending on which quadrant x over 2 lives in. The hard part about that is that you're not going to know, you're not going to be told where x over 2 is. You're going to be told where x lives, right? Your original angle, and you have to figure out where x over 2 lives. Okay, so we did this first one. We did part of it in class. We did the sine of theta over 2. I'm going to do the tangent of theta over 2 for you, but we're going to use the same setup that we used in class. So again, this ratio that we had for tangent was not on the unit circle, so we drew ourselves a triangle. We were told that our angle theta is in quadrant 3, so that's why we drew this down here in quadrant 3. We made our reference triangle, being careful, and both our opposite and adjacent sides were negative here in quadrant 3. And we also had to go through the process of figuring out where theta over 2 lives for sine. Now, since I know that theta is in quadrant 3, I know that theta has to be between 180 degrees here and 270 degrees down here, right? It has to be in there somewhere because it lives in quadrant 3. But to pick our pluses and minuses from these lovely formulas up here, you need to know the quadrant where theta over 2 lives, right? And so to figure out where theta over 2 lives, you're going to divide this entire inequality by 2. So if theta is between 180 and 270 degrees, dividing everything by 2 tells me that theta over 2 has to be stuck between 90 degrees and 135 degrees. 90 degrees is up here, 135 degrees is over here. I have to be in here somewhere, which puts me in quadrant 2. So that's why we picked the sign was positive, because all students take calculus. We are here in quadrant 2, so I know that sine is going to be positive and the other two are going to be negative. Okay, so we went through the sine of theta over 2, so I'm going to do the tangent of theta over 2 here for you. And with tangent, we've got a few options. I can pick this first one, in which case I would be very careful about my plus or my minus. We already found out that theta over 2 was in quadrant 2. So in quadrant 2, sine's the only positive one. So if I pick the tangent one, I know I'm going to take the negative square root of that. Does that make sense? So we could work that one with the negative in there. Or we could choose one of these guys. If you choose one of these, you don't have to pick a plus or a minus. You just plug the numbers in and kind of work through whatever comes out of your triangle. So let's see. I'll kind of show you both here. So plus and minus the square root of 1 minus the cosine of theta over 1 plus the cosine of theta. So if I pick the one with the plus or the minus in it, this is what we look like. And again, because theta over 2 is in quadrant 2, that means tangent's going to be negative here in quadrant 2. So I'm going to pick the negative. And then I'm going to use my triangle here to fill in the cosine of theta. So from my triangle over here, Cosine is adjacent over hypotenuse, so I know my cosine is negative 3/5. Now we just have to simplify. So if I'm going to simplify this, I'm going to get a common denominator on the top and the bottom. Notice my common denominator in both of those cases is a 5. So I'm going to take this one and I'm going to write it as 5/5 on top and on the bottom. Got a little bit bigger to keep everything in there. And on the top, if I subtract a negative 3/5, that's going to become a plus 3/5. And on the bottom, if I add a negative, that's going to become a minus 3/5. From here, we can simplify a little bit. 5 plus 3 is 8 on top, and I'm going to keep that common denominator of 5. 5 minus 3 is 2, and I'm going to keep that common denominator of 5 on the bottom. Now that I have a single fraction on the top and the bottom, I'm going to keep that 8/5 on top. I'm going to change this division to multiplication, and I'm going to flip the one on the bottom, and I'm going to multiply by 5/2. So now when we multiply across, notice I've got a 5 on top and the bottom. Those are going to cancel. And so I'm just going to have 8 divided by 2 left. That's 8 divided by 2. Yeah, it's just 4. This is negative square root of 4. What's the square root of 4? Yeah, it's 2. I'm going to get negative 2 out here. So I know that the tangent of theta over 2 will be negative 2. So hopefully that all makes sense. You have to pick the plus and minus depending on where theta over 2 lives. Make sure you start with where theta is and divide everything by 2 to figure out where theta over 2 lives. You pick your plus and minus, you plug your values in from your triangle, and then fight through common denominators. Now, what if I had picked one of the other versions, right? What if I had picked one of these guys? I'm going to take the middle one just for fun. And so what if I take sine of x over 1 plus cosine of x, right? I'm going to pick this one. Notice this doesn't have a plus or minus. So if I had picked this one from the beginning, I would not have had to choose that plus or minus based on where theta over 2 is. I just do the problem. And so I'm going to say, okay, well, the sine, oh, sorry, I wrote an x, but it's a theta. Theta is my angle. So I'm going to take the sine of theta. I'm going to come to my triangle here, and sine is opposite over hypotenuse. So my sine is negative 4/5. And that's all going to be over 1 plus the cosine of theta, and the cosine of theta is negative 3/5. And I've got fractions within fractions, so I need a common denominator here on the bottom. I'm going to write this one as 5/5 down here. Oops, I'm sorry. If I subtract, or if I add a negative, that becomes subtraction here. So I'll do minus 3/5 down here. I've got that negative 4/5 up here. When I do 5 minus 3, I get 2/5 down here. I'm going to keep that negative 4/5 on top, change this division to multiplication, and flip the bottom to get 5/2. And notice when you multiply across, these 5's cancel. You get negative 4 divided by 2, and negative 4 divided by 2 is negative 2. You would get the same thing either way. So in some cases, I think these bottom two are probably going to be easier because you don't have to worry about the plus or minus. You're only going to have to get one common denominator, and you're not going to have to worry about that square root. So it's a choose your own adventure, but if you kind of don't mind working with those roots, or you want to keep your process consistent all the time, you can definitely use those top couple. All right, I'm going to run through this last one with you because this is kind of a tricky bit. Go ahead and pause the video, try this one, and then we'll run through it together. Okay, so I want the cosine of theta over 2. But I don't know. Oh, sorry, these should match. These are both alphas. this should also be an alpha. Sorry, pretend that's alpha over 2 so that these are all the same angle. I don't know where alpha over 2 is, but I know where alpha lives. And notice the tangent value of negative 2/3, that doesn't live on the unit circle. The only values I get for tangent from the unit circle are 1, √3, or 1 over √3, √3 over 3, however you want to look at that. That's not negative 2/3. So I have to draw a triangle. I'm drawing my triangle in quadrant 2. So I'm over here somewhere. Technically, alpha is this guy. We are going to use alpha ref for our reference triangle. And I know that the tangent of that alpha, my opposite over adjacent, is 2 over 3. So I know my opposite side is going to be 2, my adjacent side is going to be 3, and I know that one of those has to be negative, but I'm not sure which one. So I'm going to put everything in my triangle and see if I can figure it out. So my opposite side is 2, so that means 2 goes here. My adjacent side is 3, 3 goes down here. Which one of these is negative in quadrant 2? Yep, it's this adjacent side. So that negative has to go with my adjacent side down here on the bottom. You can do your Pythagorean theorem here. 2 squared plus negative 3 squared gives me my c squared. 4 plus 9 is going to be c squared, which means c is plus or minus the square root of 13. Because this is a hypotenuse, it's going to be a positive square root of 13. And so now I have my triangle. I need to find the cosine of alpha over 2. So we can come up here and grab my formula here. It's going to be plus or minus the square root of 1 plus cosine of alpha all over 2. And that whole thing is underneath the radical. I can get the cosine of alpha here from my triangle. The cosine of alpha here, I'm going to use my triangle. I'm going to do adjacent over hypotenuse. And from my triangle, this is going to be negative 3 over √13. That is the cosine of alpha. Okay. From here, we're going to fight through the algebra. I need a common denominator up top. That's √13. So I'm going to write 1 as √13 over √13 minus 3 over √13 all over 2. Now I can add √13 minus 3 is whatever √13 minus 3 is, keeping that common denominator. And I've got 2 over 1 here. And so now we will simplify here, and we will keep the top, change this division to multiplication, and flip that other one. So we have plus or minus the square root of √13, minus 3 all over 2 times √13. This is kind of ugly. I want you to just leave it like that for me. I think Alex should take it in this form. If it won't, make sure that you rationalize here on the bottom. So to rationalize, you can multiply top and bottom here by √13 inside. And so if you need to rationalize there, you distribute this √13, so you'd get 13 minus 3 times √13. This is just a 13 because √13 times √13 is just 13. And on the bottom, I get 2 times √13 times √13. That's 2 times 13, which is 26. So you can also write it like this for Alex if it freaks out about having radicals in the denominator. All right, the last hurdle that we have here is to pick the plus or minus. So whether this is positive or negative depends on where alpha over 2 lives. But I don't know where alpha over 2 lives. I know that alpha is in quadrant 2, which means it has to be between 90 degrees and 180 degrees over here. Okay, so I know that alpha is between 90 degrees and 180 degrees. But I don't really care where alpha lives, right? I want to know where alpha over 2 lives. So I'm going to divide everything by 2 here to get alpha over 2 there in the middle. This becomes alpha over 2, and this says it's stuck between 45 degrees and 90 degrees. 45 degrees is here, 90 degrees is up here. I'm in here somewhere, which means alpha over 2 is in quadrant 1. In quadrant 1, cosine is positive, so this is going to be positive. Square root of 13 minus 3 root 13 all over 26, and that is your final answer. All right. I hope that helps with these in ALEKS. Happy trig identitying, and I will see you next time.